Welcome to EduNovo's practical session of focal length of a convex mirror. A convex mirror is also known as a diverging mirror as it diverges the light rays incident on it. In our day-to-day life, we use convex mirrors in the vehicles as rear view mirror to obtain a wider field of view. These are also used as reflectors in the street light to diverge the light over a large area. Before going to the experiment, let's get familiar with the terminology of the convex mirror using a ray diagram.
Consider a convex mirror. As you can see, this is the reflecting surface. As you turn around the mirror, you can see the non-reflecting surface. The curved line M' that is, the diameter of the circular rim of the mirror is called aperture. It is the part of the mirror through which light ray enters. The center of the spherical surface of the mirror is called the pole of the mirror. It is denoted by P. The convex mirror we consider is part of the spherical shell. The center of the spherical shell is called the center of curvature. It is denoted by C. When you join the center of curvature C and the pole P, the straight line is called the principal axis. If the incident rays on the mirror are parallel to the principal axis, then after reflection they diverge outwards. But they appear to be coming from the convex mirror. If you extend the reflected rays backward, they meet at a point on the principal axis. This point is called the principal focus. It is denoted by capital F. The distance between the pole P and the center of curvature C is called the radius of curvature PC. It is denoted by capital R. The distance between the pole P and the principal focus F is called focal length of the mirror PF. It is denoted by small f. The aim of this experiment is to find the focal length of a given convex mirror using a convex lens. The apparatus required to find the focal length of a convex mirror are optical bench with 4 uprights, convex mirror, convex lens, knitting needle, and half-meter scale.
Before starting this experiment, it is very important to understand the setup of the optical bench to determine the focal length of the convex mirror. As you know, a convex mirror always forms a virtual image. As it always forms virtual image, it is impossible to determine its focal length by direct method. So, we need to take the help of a convex lens to determine its focal length. Let us get a clear picture of the arrangement of the optical bench and the procedure to perform the experiment.
Consider a convex lens and mount it on the optical bench. Now, place the object needle at a distance of 1.5 times the rough focal length of a given convex lens. Now, mount the convex mirror on the right side of the lens. By adjusting the positions of the uprights, you will observe an inverted image of the object needle. Now, if we remove the convex mirror, the light rays from the object needle will meet at the center of curvature of the convex mirror. To locate the center of curvature, we mount another upright known as image needle. Adjust the position of the upright and you will observe an inverted image of the object needle on the tip of the image needle. The distance between convex mirror and the tip of the needle gives us the radius of curvature of the convex mirror. Half the radius of the curvature gives the focal length of the convex mirror.
Now you are familiar with the experimental setup and how to perform the experiment. Let us start the procedure by determining the focal length of the convex lens used in the experiment.
Here, we need to obtain the image of a distant object on the screen. When you look at the window, you can see the tree which is a distant object. Face the lens towards a distant object and obtain its inverted image on the screen. Once you got the inverted image, move the lens forward and backward until you get a sharp image. Now, with the help of a scale, measure the distance between the lens holder and the screen, which is nothing but the rough focal length. Here, it is 10 centimeters.
After finding the rough focal length of the convex lens, we place the lens in a holder and now place the lens in one of the upright. Now mount the upright on the optical bench at a convenient position. After that, we take the convex mirror and place it in a holder. Fix the mirror in another upright and mount the upright on the optical bench such that the reflecting surface of the mirror facing the lens. Now, take the object needle and fix it in another upright. Mount the upright on the optical bench such that the convex lens comes between the mirror and the object needle. As we found, the focal length of the lens is 10 centimeters. The position of the object needle should always be beyond the focus of the lens. Here, the lens is placed at 50 centimeter mark on the optical bench. We have to adjust the position of the object needle so that its position should be below 40 centimeter mark on the table. After mounting the convex mirror, convex lens and the object needle at their respective places on the optical bench, we move to the zero end of the optical bench to observe an inverted image of the object needle looking into the convex lens. Closing one eye, look into the lens and adjust the positions of mirror, lens and the object needle until an inverted image of the object needle is seen. Now we adjust the positions of the uprights to get an inverted image of the object needle. Here you can see the inverted image of the object needle. Now, by giving lateral motion to the object needle, we bring the tip of the object needle and the tip of the inverted image in the same vertical line. After that, we adjust the height of the object needle so that the tip of the object needle coincides with the tip of the inverted image. Here, as we move our eye to the left and right, there is a relative shift between the object needle and its inverted image. This is nothing but parallax. To remove parallax, move the uprights back and forth. Now, you can see as we move our eye to the left and right, there is no relative shift between the object needle and its inverted image. So, parallax is removed. After removing the parallax, we have to note down the positions of the convex mirror, convex lens and the object needle. As you can see here, the position of the object needle is at 6 centimeters. The position of the convex lens is at 45.5 centimeters and the position of the convex mirror is at 54.6 centimeters. In the absence of the convex mirror, the convex lens forms an inverted image of the object needle at the center of curvature of the convex mirror. Now, to locate the center of curvature of the convex mirror, we place an image needle on the optical bench. I am looking into the convex lens and adjusting the position of the image needle until the tip of the image needle coincides with the tip of the inverted image of the object needle without any parallax. Here you can see the tip of the image needle exactly coinciding with the tip of the inverted image of the object needle without any parallax. After removing the parallax error, we need to note down the position of the image needle. Here, as you can see, the position of the image needle is at 100.5 centimeters. The position of the image needle is at the center of curvature of the convex mirror. The distance between the convex mirror to the image needle gives the radius of curvature of the convex mirror. Half of that is the focal length. To find the index error, we use a knitting needle. Now, let us find the length of the knitting needle using the scale engraved on the optical bench. Here, the length of the knitting needle is 25 centimeters. Now, we adjust the knitting needle such that one end of the knitting needle touches the pole of the mirror and the other end of the knitting needle touches the tip of the image needle. As the length of the knitting needle is 25 centimeter, the actual distance between the pole of the mirror and the tip of the image needle is 25 centimeters, whereas the distance between the two index marks on the uprights is 25.5 centimeters. Therefore, the observed measurement is 0.5 centimeter more than the actual measurement. Therefore, we need to subtract 0.5 centimeters from the observed measurement to get the correct measurement.
We have found out that the rough focal length of the convex lens used in this experiment is 10 centimeters. Table for determination of focal length. Position of convex mirror M in centimeters. In the first arrangement, the object needle, convex lens and the convex mirror are placed on the optical bench. The inverted image of the object needle was observed on the object needle when the convex mirror was at a position of 54.6 centimeters. Image needle I in centimeters. In the second arrangement, the convex mirror is removed and the image needle is placed on the optical bench. The inverted image of the object needle is formed on the image needle. Then, the image needle was at a position of 100.5 centimeters on the optical bench. Observed distance Mi in centimeters is 100.5 centimeters minus 54.6 centimeters, which is 45.9 centimeters. Actual distance Mi in centimeters. Actual distance Mi in centimeters is equal to observed distance Mi in centimeters plus index correction. Index correction E is equal to minus 0.5 centimeters. Therefore, actual distance is equal to 45.4 centimeters. Focal length F is equal to R by 2 centimeters, that is 45.4 by 2, that is equal to 22.7 centimeters. Similarly, the other readings are as follows. Mean focal length of the convex mirror is 68.2 by 3, which is 22.73 centimeters. Focal length of convex mirror. Precautions. Principal axis of the lens should be horizontal and parallel to the metal rods of the optical bench. All the uprights on the optical bench should be vertical and rigid. The tip of the needle, center of the mirror and center of the lens should be at the same horizontal level. The eye should be kept at a minimum distance of 30 centimeters from the needle while removing the parallax. Tip to tip parallax should be removed. Index correction should be applied between the image needle eye and back surface of the convex mirror. The distance between convex mirror and the convex lens should be minimum. After removing parallax, the position of the convex lens and the object needle should not be changed.
I hope now you are able to determine the focal length of any given convex mirror on your own without any doubt or hesitation. Thanks for watching this experiment.